Hello everyone. Today we're going to go over our next part of our notes, which is the acceleration and distance or displacement. So we can use, whenever we know an object is accelerating, there are certain equations we can use to determine how far something has traveled. Because every single second the object is going faster, and as they're going faster, they're also covering more space. They're covering a bigger distance. And there are equations that we can use in order to calculate how far someone's going to be going. Or maybe I want to try to calculate some of the other variables too, which we'll use this equation to solve for acceleration. Don't worry, just like with the basic acceleration equation, the equation gets rearranged for you guys. So what is the equation we'll use? The distance is equal to the initial velocity multiplied by the time plus 1/2 or 0.5 multiplied by the acceleration, multiplied by the time squared. Now, one thing to be noticed of, only the time gets squared, not the entire term. So we're going to go ahead and go over to the example problems. We'll work those out and how to use this equation. So it says that a car is traveling at a speed of 1 meter per second. That is our initial velocity, 1 meter per second. It accelerates at a rate of 2 meters per second squared for 3 seconds. Meters per second squared, the only thing that we use this units for is for acceleration. And takes 3 seconds. Seconds measures our time. How far does the car travel? How far is going to ask for distance. When I have an initial velocity, d equals vi multiplied by t plus 1/2 at squared. I'm going to plug in my numbers. The velocity is 1 multiplied by the time, which is 3, plus 1 divided by 2 is 0.5. The acceleration is 2 multiplied by 3 squared. Now I can go through and type this in my calculator. And if you are using the Google calculator, I'll come over here to this page. 1 times 3, that gives me 3, plus 0.5 multiplied by 2, that was the acceleration, multiplied by 3, x to the y, squared. I need to make sure that I put that square, attach it right to the 3. I do not want to do equals and then square everything, because that's going to give me 9 as an answer. Now I can do this in my head too. Half of 2, which is 1, multiplied by 3 times 3, which would be 9. And the distance then is equal to 12 meters. Okay. But please be very careful whenever entering this, because only the time gets squared. Just because this has meters per second squared as a unit doesn't mean that the number is squared in the equation. Please do not make that mistake. Now, whenever we have, a lot of times when we use this equation, our initial velocity is 0. So what happens to our equation if our initial velocity is 0? Well, 0 times t, or 0 times anything, is just 0. So that whole term goes away. And what our equation ends up becoming is d equals 1/2 at squared. Or if you don't like this fraction, we can always write it as 0.5 at squared. Either one. It's both the same thing, because 1 divided by 2 is just equal to 0.5. A couple examples now. We'll start out. Car starts from rest. If it's starting from rest, our initial velocity is 0 meters per second. It accelerates at a rate of 5 meters per second squared. Meters per second squared is our acceleration. And goes for a total of 4 seconds. How far does he go? This is my question. Since my initial velocity is 0, I'm just going to use that other version where I have 0.5 at squared. D equals, want to plug in my numbers, 0.5, multiplied by the acceleration, 5, multiplied by 4 squared. And again, I'll type this in my calculator, 0.5 times 5 times 4 to the second power equals 40. D equals 40 meters. Next example, Matic starts from rest, VI is 0 meters per second, accelerates at a rate of 3 meters per second squared. Meters per second squared is an acceleration. Only thing we measure meters per second squared in is acceleration. 10 seconds is our time. How far does he travel? Want me to solve for D again. I'm going to write down my equation, 0.5 AT squared. I'm going to plug in my numbers. D equals 0.5. Acceleration, which is 3 times 10 squared. Again, make sure you don't forget about the square. Now you might be asking, Mr. Rupika, you were putting in parentheses, and in the calculator you're putting in multiplication. I can do the parentheses as well, 0.5 times my acceleration, which was 3. Oops, actually, sorry, I started 3, and my time was 10 seconds. Close parenthesis, square that guy, equals. That's going to give me 150. Now again, I'll do this without the parentheses, but multiplication, 0.5 times 5 times 10 to the squared power. Oops, I guess it'd help if I use the right numbers. 0.5 times 3, not 5, times 10 squared. And when I use the right numbers, now I'm getting 150, the same answer as whenever I use the parentheses. It's just one way, or it's just how I was taught to show my work, was putting inside parentheses when I was younger. Okay, so we don't always just solve for the distance. Sometimes we will solve for the acceleration. So again, whenever our initial velocity is 0, how can we solve it? The acceleration is equal to 2 multiplied by our distance divided by our time squared. Please make sure that you square the time down in the bottom, just like we were doing. Now here it's going to ask us to solve for 2 parts. It's asking us for the acceleration. Once I have the acceleration over here, then I can use that over here to solve for the final velocity. This is a 2-part example. It says the car originally starts out from rest. 0 meters per second, 0 meters per second. Speeds up for 5 seconds. 5 seconds is our time. 5 seconds is our time. Travels 40 meters. 40 meters. At what rate did the car accelerate? So as I take a look here, since I don't know the acceleration, but I know these 3 things, I'm going to start over here with this side first. Once I have the acceleration, then I can use that to solve for the final velocity. So solving for acceleration, 2d divided by t squared. And if I'm solving for a final velocity, the version of the equation from our notes from our last set of problems was vi plus at, whenever I'm solving for that. But first, I need to figure out what is the acceleration. Acceleration is 2 multiplied by 40 divided by the time squared. So I want to type this in my calculator. 2 times 40 divided by 5. And again, since I have this square, I need to press x to the y squared. If you're using a regular calculator, you can use the squared button. which one, the blue one, happens to be right here beside the 7. If you're using one of the math calculators, I believe it's over on the left-hand side. I don't have any of those in front of me at the moment. Our answer then for the acceleration is 3.2 meters per second squared. And whenever I know the acceleration, I can use that over here to solve for VF, where it's VF equals 0 plus 3.2 multiplied by 5. And I can just type this right into my calculator. 0 is just 0. So 3.2 times 5 is going to give me a total of a final velocity of 16 meters per second. So using this new equation to solve for the acceleration, then using in one of our other ones to solve for another variable. Let's check out our last example two more examples. Thought that was the last one. My bad. Charlotte starts from rest. Rest means initial velocity is 0. Runs for 15 meters. 15 meters is a distance. The only one that I have distance is for the new equations with distance equals 0.5 at squared, or a equals 2d divided by t squared. 10 seconds is our time. 10 seconds is our time. Oops. So I put this in the right spot. Want to know the final velocity and want to know what is the acceleration. A equals 2d divided by t squared. 2 times 15 divided by 10 squared. 2 times 15 divided by 10 squared equals. Acceleration is 0.3. And once I have the acceleration, solving for VF, it's just VI plus AT. Initial velocity is 0. Acceleration is 0.3 multiplied by 10. That equals VF. And 0.3 times 10 is equal to a final velocity of 3 meters per second. Here is the last example. Maddox starts from rest. VI is 0 meters per second. Accelerates at a rate of 4 meters per second squared. That is acceleration, 15 meters. How far does he go? How far is going to ask for distance? When I'm solving for D equals 0.5 AT squared. That's 0.5 multiplied by the acceleration 4 multiplied by 15 squared. 0.5 times 4 times 15 squared equals 450 meters. Well, nice thing with this one. Acceleration still 4. Time is still 15 seconds. But I could have started with this one first since I already knew everything else. VF equals VI plus AT. 0 plus 4 multiplied by 15. Oh, that is terrible handwriting. Sorry, guys. Plus A, which is 4, and the time, which is 15. And the final velocity, 4 times 15, is going to give me a final velocity of 60 meters per second. And that's it for the acceleration and distance notes.